Welcome back to another episode of Derivatives Examples, where I basically run through three examples that I've written up for you. This is the 9th episode, which means from 1 up till now they have gotten progressively harder, and I've used new techniques that you will come across when facing derivatives, and in my further videos they will get even harder. So these are the three examples, and I will go them in order. Example 1, we have y equals cos 1 minus e2x over 1 plus e to the power of 2x. We're going to use a chain rule to solve this. Be the derivative of the outside function, negative sine 1 minus e2x, 1 plus e2x, because the inside stays the same, and then we find the derivative of the inside. So we're going to label this part u and this part v. Then it's going to look like u dash v minus u v dash over v squared. Just going to rewrite this out. Now we can get on with the question. U is the top part, and the derivative is going to be negative 2e2x. Why? Because the negative stays, and e to the 2x stays, but you multiply it by the derivative of the 2x, whatever's the power. And so the derivative of that is 2, so it's 2e2x. Write out v. V is 1 plus e to the power of 2x, and minus u, 1 minus e to the power of 2x, derivative of v. Derivative of e to the power of 2x is 2e2x. All over v squared, 1 plus e to the power of 2x squared. Next step. What I'm going to do is I'm going to multiply this negative into this. So it's going to get rid of the negative at the front here and the negative there. So it's going to look like 2e to the power of 2x, 1 plus e to the power of 2x, plus 2e to the power of 2x, 1 minus e to the power of 2x. And I'm going to split the fraction while I'm at it. And that is all multiplied by the sine of the stuff in the brackets here. I haven't got much room, so I'm just going to do a dash. Okay, we're not done with the question yet. Okay, let's see if we can rewrite it with some room. So this top part here, well, we can get rid of the 2 and we can get rid of this part altogether because it's the same. This bit isn't the same, so it has to stay. So what we're left with is okay, well, if you look closely you can see that there's a 2e2x and a 2e2x. That means that we can actually factor that out. Therefore, what we're left with is 2e2x bracket 1 over 1 plus e to the power of 2x plus 1 minus e to the power of 2x over 1 plus e to the power of 2x squared sine 1 minus e to the power of 2x 1 plus e to the power of 2x. And that is your answer, and is your question answered. Basically, if I was to expand these brackets and multiply this in, it would look like this. Okay? Now, that's only example 1. We've still got 2 more to go if you want to stick around. So example 2, which is y equals ln x squared multiplied by sine x. We're going to use the product rule. This is going to be u, and this is going to be v. Okay, so the derivative would be u dash v plus uv dash. The derivative of u, well, we're going to have to use a chain rule, so we're going to have to bring the 2 down, leave the inside the same, and then multiply by the derivative of the inside, which is 1 over x. Multiplied by v, sine x, plus u, which is ln x squared, derivative of v, which is multiplied by cosine x. Okay, so if we rewrite this, what we get is, well, we can factor out an ln of x, only 1, because there's 1 multiplied in. So ln of x, there's 2 over here and 1 over here, so 1 will stay inside, but 1 will go away. 2 sine x over x plus ln of x cos x. Now, it's your choice to factor out the ln of x. It wouldn't really change much. I just felt like it, and it works. It's not like I'm drastically doing anything dangerous, but yeah, you can factor out the ln of x, which is what I did. And all I did here was just multiply the sign on top of the fraction and the 2 on top of the fraction, which is what you get here. Okay. Now for our third and final example, we have y equals tan of ln of ax plus b. Okay, this one is pretty basic. I just wanted to try and show you that working with letters is nothing. It's just like working with numbers. So, outside, derivative of tan, sec squared, so it stays the same. Multiplied by the derivative of the inside, which is just 1 over ax plus b, multiplied by the derivative of the innermost function, which should be a, because ax plus b, derivative of that is a. And then what we end up with, I should write the derivative there, is a sec squared ln of ax plus b ax plus b. And that is your derivative. Thank you for watching. I hope you learned something and have a good day.